Now, today our lesson is talking about the product and quotient rules. We said that if we have two functions that can add it or subtract it, it can be differentiated. If it is added or subtracted without a rule. That's mean if you have 3, I'm asking you to find the derivation of 3x squared. Okay, or if the functions here, one of them is a 3x squared and the second is 2x squared. I'm asking you now to find the derivation of it. One of you said, teacher, can I differentiate each one and then add it? And one said, teacher, can I add them first, then I differentiate? So one of you want to find it as derivative of summation and the other you want to find the summation of the derivative. Let's start now with the first one. The first one, he wants to find the summation, then the derivation. The summation first, then the derivation. The summation of 3x squared plus 2x squared is what? 3x squared plus 2x squared. The summation is 5x squared. So Hannah, as an example, teacher, can I add them first? Then I differentiate? I can say yes, because 5x squared, if it is added, it will be the two of them, it will be 5x squared. And then if you differentiate them, if you differentiate the summation, you have 10x, which is 5 times 2x, which is 10x. And the other one, like Tala, as an example, she told me, teacher, can I find the derivation first, then add them? Let's see. The summation of the first, let's find the derivation of 2x squared, and then find the derivation of 3x squared. The derivation of 2x squared is 2 times 2x, which is 4x. And for the 3x squared, as we said, it's 3 times 2x, which is 6x. And then after that, you want to add the derivation. And if you add them, you have a 10x now. So both of Hannah and Tala did the same, have the same answer. So the derivation, so because of that, I can say now the derivation of, or the derivative of summation is equal to the summation of derivative. That's why I told you that the derivation can be added or subtracted. But let's see in the multiplication, can we have the same answer? Let's see now. Let's see if the summation, if the derivative of a product is equal to the product of derivative? Let's see here. Here we have two functions. These two functions are multiplied. 3x squared and 2x squared. The first one, she told me, teacher, I want to multiply them. First, multiply. And second, find the derivation. So the first thing, she wants to multiply, then she wants to find the derivative. The second girl, she wants first to find the derivative and then multiply. Let's start now with the first one. In the first one, she multiplied 3x squared and 2x squared. I'm talking about these two functions also. 3 times 2 is 6. X squared times x squared is x raised to the power 4. So she multiplied them. After that, she wants now to find its derivation. And its derivation is 6 times 2x, 4, this is 4, not 2. So, 4x cubic. And the answer is 24x cubic. This is the answer. So, the derivation of a product is 24x cubic. Let's do the second thing. In the second thing here, let's find the derivation first. What is the derivative of 3x squared?
Outside and
3x.
It will be 3 times 2x,
3
which
out
is 6x.
2 over 1.
And for the second one, it will be 4x, is right? 2 times 2x, which is 4x. And if you multiply them now, what you will get? I want now to find the multiplication of 4x and 6x.
24x squared.
You will have, thank you. You will have 24x squared. Now, let's compare the answers of the derivative of a product with the product of the derivative. Are they the same?
No.
No. So because of that, I can say that the derivation of a product cannot work by finding the derivative, then multiply. So if there have two functions, so this one is false. If you have two functions that are multiplied or three functions, you can first multiply them, then find the derivation, or you have, but this one can work on the simplest functions like x, 2x, 4x, but sometimes for the complicated one, there's a theorem. We call it a Lipin's theorem. It helped me to find the derivation. This is our theorem. In it, we say that if you have two functions that are multiplied, f and g, these two functions are multiplied. I want you first to write it like this: fg plus gf. Then, first prime, I mean the first derivative of f times g plus g prime times f. This is a rule or a theorem. We called it a product rule. This one helped me to find if we have two functions that are multiplied, how can we find its derivative? I pick the first function, I find its derivation, multiplied by g, plus the derivation of the second function, multiplied by f. or you can write it as here f of x times the derivation of g of x plus g of x times the derivation of f of x. So the f times g is f prime g plus g prime f. Is it clear now?
Yes, teacher.
Let's now do the first example here. The first one here, he asked me find the derivation of y with respect to x if y is equal 4x squared minus 1 times 7x cubic plus x. Now, here the functions are not added, are not subtracted. It's multiplied. So, if I have two functions that are multiplied, I say it's f prime g plus g prime f. So every time if it's multiplied, the first thing I want you to say, here you have the first function and the second function. I want you now to name each one. Like, let's say this is f, and let's say this is g. The first function is f, and the second function is g. This is the first step. Then, the second step, here, make a corner, and find f prime and g prime. I name f and I name g. I want now to find the derivation of f and the derivation of g. This is the first step before doing anything. Let's now find f prime. What is the derivation of 4x squared?
8x.
Is
8x.
It will
4
be,
outside and 2x to the power 1.
thank you, minus 0. So it is 8x. This is for f prime. Now, let's do now g prime. What is the derivation of it? It is 7 times 3x
X to
squared.
the power 2.
Is it right?
Yes.
Plus what?
Plus 1.
Plus 1. So the answer here is 21x squared plus 1.
Plus 1.
This is now g prime. Is this clear?
Yes.
Okay. Now let's continue.
Miss, please may you repeat it?
How can I find f prime and g prime?
Yes.
Okay. Now, f prime. For f prime here, where is f? It is 4x squared minus 1. Is it right? This is f. What's the derivation of it? Yes, Lana.
8x.
It is 4 times 2x, yes, which is 8x. And what's the derivation of g?
21x squared.
Well, you know it. Why do I want you to repeat it?
بس هيك فكرت في شيء. Okay.
21x squared plus 1. This is the first step. I found f prime and g prime. Then the second step, I want now to find the derivation. Oh, I want now to use the power rule. I told you here in the pink, in the here, f times g. I told you now, if you want now to find f times g, you have to say f prime g times g prime f. Do you have now f prime? Do you have g? Do you have g
Yes.
prime? And I have f. So I just now evaluate. Yeah. Where's f prime?
8x.
Is
8x.
8x times. Where is g?
21
x
x
squared
x
plus
to
1.
the
No.
power 2.
G, not g prime, g. This one.
7x cubed plus
Cubic
x.
plus
So
x.
it will be 7x cubic plus x. This is the first one, f prime g plus. Now, g prime f. Where's g prime?
21x
It is
squared plus 1.
21x squared plus 1 times what now?
4x.
Where's f?
4x
4x squared
4x
minus 1.
squared minus 1.
Minus 1. Thank you. Is it clear?
Yes.
Yes, teacher.
Then let's simplify or multiply, you can say. 8 times 7, it is 56x to the power 4 plus 8x squared plus, I just multiply them, plus, let's multiply now these two functions. 21x squared plus 4 times 4x squared is 84x to the power 4
To the power 4.
minus 21x squared. I just multiply 21x squared with negative 1 plus 4x squared. Now let's multiply 1 with this one minus 1. Is it clear how to multiply them to binomial functions?
Yes, teacher.
Then after that, it will be 56x raised to the power 4, 8x squared. I'm sorry, here we have also minus 84x to the power 4 and 8x squared minus 21.
Why minus?
Where?
Minus
Sorry,
84.
plus. Thank you. Plus minus 8 with negative 21 and with a plus 4x squared minus 1.
Miss y to the power 4.
Here.
No, I mean 56x to the power 4 plus the answer with the.
Sorry, I write it as squared. Thank you. No, there's 2 here.
Miss, no, I mean down.
Down. Where's down? Here?
No, not here.
Here?
No.
Here?
Down, yes, down.
I just gather them. I
Miss,
just put the x to the power 4 in bracket and x squared in another bracket to simplify.
I mean, yeah, here in the 5x, 56
x to the power 4. Okay.
Plus with the pink, plus 84x to the power 4. It's
okay.
the power 2, not 4.
No. It's this one.
I'm here, down.
Yeah, miss. Okay, I put it here. I rewrite the equations. Shahid, I bring 84x to the power 4 and I put it here. Then I will put this one here.
Oh, okay.
Then after that, 56 plus 84 is? Yalla, 56 plus 84. It is 140. Thank you. So it's 140. X to the power 4. I just added them. Plus 8 times minus 21 plus 4. 8 plus 4 is 12. Minus 21.
Negative 9.
Negative 9. Thank you. So
Negative 9.
negative 9. X to the power 4 minus 4. This will be the final answer.
Teacher,
Yes.
can you please repeat the last steps?
Here?
With the purple.
With the
Yes.
here, you mean? Okay.
Yes.
This one here, Mihat, I have now the green one here, or the greens, this one. Okay. Do you know from where I bring it?
Yes, teacher.
Okay. Now I just retype the equation or the functions. I put the to the power 4 in one bracket, like let's see here. The first one, which is 5x 56 x raised to the power 4 and 84 x raised to the power 4, and I gather them in one bracket. And I added them 56 plus 84, it was 140. The second one, I now add the ones that have x raised to the power 2, which is 80x squared and negative 21x squared and 4x squared. I put them down in one bracket. And then I simplified. 8 minus 21 plus 4, the answer is negative 9. And minus 1, I keep it as it is. This will be the final answer. Is it clear?
Yes, teacher. Thank you.
You're welcome. Let's now do another example. This one here now. Find ds over dt. Now look at this function here. Why it's written as ds over dt? The function here is s equal 1 plus t times square root of t. So the function here is s, and the terms is with y, with the t, sorry. Which is, if you say y equal 2x, you write it as dy over dx, its derivative. Here now, it's mean I want to find the derivation of y with respect to x. Here, I want to find the derivation of s with respect to t. That's why he write it as ds over dt. Now back to our lesson. Here now, so ds, I want now to find ds over dt. If you know that s is equal 1 plus t times square root of t. As I told you now, here you have the first step, you have to name this one with F, and this one with G. So the first step, you name it with F and G. The second step now. So F is 1 plus T. So what it will be F prime?
0 plus 1.
Thank you, which is 1. Now, what is G? It is square root of T. Or you can write it as T raised to the power half. Is it right?
Yes.
Yes.
I want now to find G prime. For each function, you have to find its derivative. What will be G prime?
Half T to the power negative half.
Half T to the power negative half. Thank you. Or you can write it as half T, T1 over T to the power half, which is the square root of T, and 2 down, which is 1 over 2 T raised square root of T. Then I have now F, I have now F prime, I have now G and G prime. Let's now find the derivation of the multiplication using the power rule. The power rule said that S prime is F prime G times G F prime. Now, let's now evaluate. Where is F prime? It is 1.
1.
So I bring now the 1 and I put it here. Where is now G?
Square root of
G
T.
It is square root of T.
is T. T.
This one. So I write it here. And I multiply them. What's happened here? سوري يمكن الشاشة علقت شوي بس. Okay, girls, please, you can now leave the meeting. Tomorrow I will continue. Do you have any question?
No, Miss, thank you.
No, teacher.
Thank you.
Thank you so
Thank you.
much. Thank you for listening. I'm sorry for what happened.